For company A, there's a 60% chance that no claim is made during the coming year. If one or more claims are made, the total claim amount is normal with mean 10,000, standard deviation 2,000. For company B, there's a 70% chance that no claim is made. If one or more claims are made, the total claim amount is normal with mean 9,000, standard deviation 2,000. The total claim amounts of the two companies are independent. Calculate the probability that in the coming year, company B's total claim amount will exceed company A's total claim amount. So let A be a random variable denoting the claim amount for company A and B denoting the claim amount for company B. So we have to find probability B greater than A. Now there are two cases where B can be greater than A. Case one, no claim is made by A, and then as soon as any claim is made by B, that amount will exceed the A claim amount because the A claim amount is 0. So in this case, what we need is that no claim is made by A and some claim is made by B. So we multiply the two. So no claim made by A is 60%, as mentioned here, 60% that no claim is made by A. And some claim made by B would be 30% because there is 70% that no claim is made by B. So no claim made by A, 60%, and some claim made by B, 30%. That gives us 0.18. So we call this P1 because this is a partial probability of what we need, because this is just one possible situation in which the B amount can exceed A amount, and that was when no claim was made by A. So there could be another case that when a claim is made by company A, then not only does a claim also have to be made by company B, but that claim amount of company B should also exceed the claim amount of company A. So in this case, we are talking about three things. A claim is made by company A, that forces a claim to be made by company B, and then we should also have the B amount exceeding the A amount. So let's first focus on the main thing, which is the B amount exceeding the A amount. So in this case, we are told that the A and B claim amounts are normally distributed. And since we are looking for B greater than A, so we focus on the variable B minus A. B will be greater than A when B minus A is bigger than 0. So let X be equal to B minus A. Since B and A are independent normals, so X will also be normal. So the mean of X will be the mean of B minus mean of A. Mean of B was 9,000. Mean of A was 10,000. 9,000 and 10,000. And so the mean of X is negative 1,000. And then the standard deviation, as we discussed before, if we have a linear combination, then we have the coefficient squared times the individual standard deviation squared, and we add them all up and take the square root. So the standard deviation of X will be the square root of the standard deviation squared of B, and then here the coefficient is negative 1, so plus negative 1 square and sigma squared A. And both these standard deviations of B and A were 2,000 as given in the problem. And so this ends up being 2828.4. And we are looking for probability B greater than A, which means B minus A greater than 0, which means X greater than 0. And the normal tables that are given to us are the standard normal tables. So we have to change this into a z-score. So 0 is the key number, which we have to change into z-score. So our formula is X minus the mean over standard deviation. So 0 minus the mean over standard deviation for the X, and that's 0.35. And therefore, probability X greater than 0 means probability Z greater than 0.35. And the tables, if you remember, are given in the less than direction, Z less than some number. So we have to convert the greater than into less than. So Z greater than 0.35 would be 1 minus P less than equal to 0.35. and the less than equal to 0.35 now can be read from the table, and 0.3 here and 5 here, so that's 0.6368. So we'll have 1 minus 0.6368, so 0.3632. And now we're in the position to write down the P2 of B bigger than A. And in this case, remember, we started by saying that A makes a claim and then B also needs to make a claim. So A making a claim was 30%. And actually, A making a claim was 40% and B making a claim was 30%, but doesn't matter. Let's write the correct order. A making a claim was 40% and B was 30%, because remember, not making claims were 60% for A and 70% for B. So in this second case, we need A to make a claim and B to make a claim, and the claim amount of B exceed the claim amount of A, which we calculated here to be 0.3632. And so we multiply the 3, we get 0.0436. So that gives the partial probability of B greater than A in the second case. And these are the only two possible cases where B could exceed A. And so the final probability of B being greater than A would be the sum of those two partial probabilities, P1 and P2. P1 was 0.18 here, and P2 we've just found to be 0.0436, and they add up to 0.2236, which rounds to 3 decimal places. That's 0.224, and 0.223 is the closest answer by far. And the discrepancy that we see is because we employed some very generous roundings along the way. So we know that the correct choice is D.